Welcome back. Today we're going to be looking at sets in Python, and in Python sets are the same as they are in maths. The idea is taken in the same way, but really to say what a set is, we would say a set is a collection which is unordered and unindexed, and in Python you use curly braces to do that. And unlike a list, which has an order, you can say which position each thing is in, and an index, so you have indexes 0 to the length minus 1. A set doesn't have that. You also can't have duplicate elements in a set, and we'll see how that works. So for sets there are a lot of method. Most of the time these don't get used, but some of the main ones are add, remove and update. But before we want to look at sets, we want to look at this magic word in, which we haven't seen yet and is another purple word. So let's start by looking at in. So here we've got x and xy, and we're checking if x is in this item that has that in. So if we look at this first one, we've got a list, the second one a tuple, and the third one a set, and we're seeing if the value x is in the thing on the right. And here it is, and here it isn't. So we can run that and see that we get true for the first ones and false for the second ones. So the way you define sets is by saying the set is equal to, and then you've got curly braces and then commas separating each item of your set. And you can also have a list and turn it into a set using the set function. And then here we've got duplicates in our set, so we'll just delete them automatically. And here we've got duplicates in our list, so we'll delete those when it turns it into a set. So we'll print out each one separated by a new line. And there we go. And the reason they're not in a normal order is because they're unindexed and unordered, and this is due to hashes. Like lists, in set you can use a for loop to go through each item. So here we're looping through each item in the set and printing the item. Here we're adding something to the set. You can only add one item using add, and then we print out set 1. And with Python notebooks, it will print out the last thing you put if you want it to print that. So it's printed out the new set with D in it. You can clear the set just by using the clear method, and you can see here it's given us a set back as opposed to actually trying to display the set, because then it would look like a dictionary, which wouldn't be very clear. Here we're using the copy. We're copying set 1 into set 4, so we now see that set 1 and set 4 are the same. Here we're taking the difference, so we're saying what's in this set that isn't in this set, and likewise what's in this set that's not in this set. And so set 4 contains a D, which isn't in set 3, and so you get the D, but set 3 doesn't contain anything not in set 4. Here we're doing a difference update, so we're saying make set 4 the difference between set 4 and set 3. So we run that and we can see that set 3 isn't going to change, but set 4 is going to become the difference between set 4 and set 3, which if you remember was a D. We can also use the discard function, which just gets rid of the thing we specify. So we can see we've removed the A from set 3. And if we then run it again, we can see that no error is generated even though we've removed the thing from S3. We can also look at the intersection, so what's in both set 3 and set 1, and we know is BC. We can then check if they're disjoint, so if they contain something that's not in the other set. So we can check if they're disjoint, see if they contain no similarities, and in this case they aren't disjoint. Then we can check if stuff is a subset, so set 3 contains stuff and set 1 contains all of that, so set 3 is a subset of set 1, but set 1 is not a subset of set 3, and then set 2 is an empty set, and set 4 is a set that's not empty, and we're saying that they're subsets of themselves, and we can see that they are. Because set 2 and set 2 are the same, it's also going to say they're supersets of each other, and set 1 is a superset of set 3, but set 3 is not a superset of set 1. You can also use pop in the same way you can with a list, and this will select a random value and then remove it, so you don't know what it's going to be until afterwards. And so we can see in this case it's remove the C to leave just the B. But if you remember set 2 is the empty set and we try to pop, it says we have an error, you can't pop from an empty set. You can also use remove if you want to remove a specific item. So if we try to remove B from set 1, you can see that set 1 is ACD. But if we then try running it again, we see that we've got a key error B, which we didn't get earlier when we used discard. Then you've got a symmetric difference, which is a bit like the difference, but it will be the same for both. So if we look at this, we see that set 3 has a symmetric difference of these values with set 1, and this one's symmetric, unlike the other one, which changed depending on the direction you went. Then we can do a symmetric difference update. This sets set 1 to all the things here, and we can run that and see that set 3 hasn't changed, it's still B, and set 1 has changed, it's gained a B, so that it's now the difference between that and set 3. You can also use a union method, which says what's in both sets combined and returns a single combined set. So we can see that in set 3 and set 4 there's a B and a D, and together you get the set BD. You can also update sets. An update is a lot like adding, but you can add multiple values instead of just one. And so we can see that set 1 has now got all of these values in. Now we'll look at a practical use as well. So shared element is saying, is there something in both lists? And so what you might do is you might loop through the first list, loop through the second list, and if there's something that's the same in both, then you return true. And if it gets all the way through and it hasn't found a match, then it's false. So you can see that these don't have a shared element and these do. We run it and it works. But if these were really, really long, it would take ages to loop through all of list 1 and all of list 2 if there wasn't a match early on. So instead, we can use this shared element. So what we do is we convert our first list, list 1, into a set, and we say, is it disjoint? So is there nothing shared between list 1 and list 2 as sets? And then we return the opposite of that. And you can see that this works a lot better and is a lot quicker and fewer lines of code. So it'll probably be a better way of doing it. So hopefully you've enjoyed this video. You've learned a lot about the use of sets and you'll be able to use them. And I'll see you again, same time next week. Till then.